commercial plane design. Okay, so almost everything is done except two part. So we will complete that part and we'll go to assembly. After that, we'll continue our next session. Okay. So last class we have done with the fuselage. Okay, and also our main wing, and after that we have completed our horizontal stabilizer, and today we will be doing the vertical stabilizer. Okay, so with respect to this vertical stabilizer, we have all these geometrical parameters. Okay, span, that is b by 2, 27 feet, chord 16.20223 feet, area 346.15149 feet square, and this section has been divided into two group. Okay, this is our first one and this is our second one. So first section parameter, we have overall span 6.5 feet, root chord and tip chord, sweep angle. Okay, so we have our all geometrical parameters. So we will use all our geometrical parameters. Okay, and we will complete our vertical stabilizer. Okay, yes. So let's open the Open VSP software. Yeah. So here we have our Open VSP software. As we know, we are dealing with the wing. Under wing, specifically, we are dealing with the vertical stabilizer. Okay. So that's why what we have to do, we have to select the wing and we have to add. So here we have our default wing. I don't know. Okay, see, this is our default wing. No, for our vertical stabilizer case, we don't need the symmetry part. Okay, so that's why what we will do, we will go to Xform and we will off the symmetry portion. Yes, here we have top view. Yeah, so currently we have only one section. Okay, so according to our geometry, what we have to do, we have to split our section into two group. Okay, first section and second section. Okay, so here we have our parameters related to our first section and also related to our second section. Okay, so we will use these parameters and we will complete our part. Okay, yes. Just let me take this thing. Okay, yes, now it's perfect. Yeah, so here you can observe we have our first section parameter. Okay, and the first section it is located here. Okay, and our second section parameter. Okay, so here we have second section. So which means in the open VSP, what we have to do, we have to split our wing into two sections. Okay, so we will come to open VSP and we will split. Now currently we have only one section. Let's split this one section. Okay, now we have two sections, section 1 and section 2. Okay, so before applying our section 1 and section 2 parameter, what we have here, okay, before applying this parameter, let's complete the main wing parameter what we have. Okay, which means overall wing parameter. Overall wing parameter, that is this one, from here to here, from here to here, again from here to here. This is our complete wing, and this parameter we have to use. Okay, yes. So overall span 27 feet. So come to the fourth tab where we have to give our overall platform parameter. Okay, for complete wing. So total platform span, that is 27 feet. 27, enter. Yes, that is done. Now after this, what we have to use chord. Okay, so how much chord? That is 16.20223 feet. Chord length 16.2022, enter. Okay, yes. Now after this, we have our next parameter, that is our area, 346.15149 feet square. One five one four nine. Enter. Okay. Yes. So this is done. Now what we have to do? We have to go to section and we have to use each section parameter in that particular section. Okay. First section. Here we have first section parameter. So we are in first section. Green indicates we are in that section, first section. Okay. So what is our span? So our case overall span is 6.5 feet. Okay, so we have to use 6.5 feet. So let's type that value 6.5, enter. And after that we have to use our chord length, that is root chord 30.5 feet. Root chord 30.5, enter.
Sir, the span
After
is
this we have
6.5,
to
sir,
use
not 16.5.
6.5. Yes, yes.
Yeah, put 16.5, sir.
Yeah, it is 6.5. Okay, default one number was there. I did not. Oh, yeah, now it's 6.5. Correct. So after this, what we have to use? We have to use our tip chord. Okay. So we have done with span, root chord 30.5. Okay. And now we have to use tip chord 14.9. Okay. Enter. Okay, this is done. And now after that we have to also give the sweep angle. Okay, 69 degree. So here we have sweep angle default 30 degree. We have to convert this 30 to 69. Just step 69 and enter. Okay, that is done. Now, yeah, first section parameter is done. Diagonal angle, no need to put any diagonal angle. I mean, no need to add a diagonal angle. That is 0. So here we have 0 itself, diagonal angle. Now let's jump to second section. Yeah, we are in the second section. And in the second section, we have our span from here to here. Okay, 20.5 feet. And we have a root chord, this one. Okay, we know it will be same what we have the tip chord of first section, that will become root chord for the second section. That's why we have same, that is 14.9. Okay, you can do these numbers, otherwise you can just neglect. Okay, I'll just give 14.9. Okay, default we have 14.9. Now just do tip chord length 4.411. Okay, 4.4118. 4.411. Enter. Okay, this is done. Now sweep angle 36 degree. So here we have default 30 degree. Change this to 36 and enter. Yes. Parallel angle 0. Okay, which means we have done with our vertical stabilizer. Only we have to add the aerofoil. That is NACA 0020. Okay, we'll come to aerofoil, and here we have to add the aerofoil. Okay, so we'll add same aerofoil NACA 0020, which means thickness to chord ratio 20%. Okay, so just change this to 2. Enter. Now observe the changes here. This also will change to 20%. Enter. Yeah. So we have done with our vertical stabilizer. Share this one. Top view, front view, and left view, and also our ISO view. Okay. Okay, what we'll do, we'll just increase the number of tessellations. Okay, now it's correct. There is no any gap. Just go to file and save this one. So this is our vertical stabilizer. We have done with our fuselage wing, and after that horizontal stabilizer, vertical stabilizer, except. Okay, so now we will go to file and new, because we have to create new geometry. Okay, yes. So we have done with this now. Now we will go to this thing, engine component. Okay. So to complete this component in the OpenVSP, you can add the default parameter, I mean like default geometry, that is pod or stacks, anyone. Okay, so by using your pod or stacks, you can create the engine component. Okay, so we will add the pod. Okay, so I'll select pod and I will add. Okay, so here in this pod, as we know, we have design parameter. Okay, so in this design parameter, just I will change the parameter as per the requirement what we have here. Okay, height, okay, width, height, shape, chord, thickness to chord ratio, and that location. Okay, here we have only two parameters now. Okay, let's take stacks then and add this one. Okay, so here we have so many parameters. Let's try this pod. In this we will change the cross section. Let's take this. Okay, this will not come. Okay, we will use this stack geometry. Yeah, so here we have our design parameter. So first cross section. So we will open this first cross section. So that's why I'll just select the circle. Okay. And go to last cross section. Here also I'll select the circle because we want to show the open exhaust thing. So we'll maintain small diameter. Okay. I'll come to first cross section. Here I will just get 2 feet. Okay. So we are not doing any analysis here. So just to show the yeah, wait. Yeah, we'll continue. So in between you can reduce the diameter or the type of fuselage, sorry, type of the cross section. Okay, so here we'll fix this part as a engine roughly. Okay, roughly we'll fix this one as a engine. No need to go up with the parameter. Okay, because some more parameter calculation is needed. Okay, so that's why we'll just take on this. Okay, we'll fix this one as a rough being a rough engine component. Okay, so I'll just go to file. I will save. Okay, I will save this one as engine component. It's just rough model, not according to the calculation. Okay, so I'll just accept. And this was part 5. Okay, so now what you have to do, you have to just go to new. Okay, and you have to call each and every part which you have designed. Okay, so I'll just go to that folder or that file where I have saved all these design models. Okay, that is fuselage, main wing, horizontal stabilizer, okay, and vertical stabilizer. Okay, so all these parts we have done. No, so those who have done, please take out your parts. So how to take out that one? Ashwin, you have asked this question, no? So just observe that. Okay, so what you have to
Yes,
do?
sir. I
Just
got
you
it. I
have to
got
go
it.
to, yeah, yes, go to file and insert. Okay, so here you have all these components. No, select each and every component and add. Okay, so I'll select the fuselage model, accept. Okay, and insert next component, part 2. That is our main wing, accept. Okay, so here I have our complete file. I'll just copy the path. Okay, just copy this path which already saved successfully. Okay, I'll just use this directory.
Sir, in the last class, you made a different wing only, sir.
Which one?
Sir, for the same Boeing aircraft, you made the wing which was there in your presentation, sir, not the one which you put it right now.
Which one? Here,
The main wing which you put here, no, sir. That
this
wing
one.
only, sir. Yes, sir.
So, yesterday we have done no main wing.
Yes, sir. We did it the same way how it was in the. Oh, yeah, it was like this only, sir.
Yeah, yeah. So
I mean, you put the other wing, so that's I got confused.
no, no, no. Yeah, that's why. That's why. That was different one. Okay.
Okay,
So
sir.
that's why I just copied this directory. No, here we have all the parts. See, part 1, part 2, part
Yes,
3,
sir.
part 4, part 5. Okay.
Yes, sir.
So that's why I just changed the directory. Actually, that was different directory. So that's why you have to ensure where you have saved the file. So I just save my file in this A folder.
Yes,
So
sir.
I'll just copy this directory and I will paste here. Okay, already pasted. So I'll just call each and every part. So how to call? Instead of going to this open, just go to insert, because we are inserting our inbuilt components or the saved components which are already done in the open VSP. Okay, so for assembly purpose, you have to go to file and you have to insert all those components. So I'll just insert part 1 and also will insert part 2. So we can fit on screen. Okay, here we have part 2 and insert part 3, accept. So select that part 3. Sometime it will get hidden up, okay, or it will just follow one above the other. So just you have to go to Xform and you have to translate that part, okay. Oh, no need to disturb along y. Okay, now again I will go to file, insert. Okay, this is our fourth part, accept, and last one, file, open, fifth, accept. Oh sorry, I just, okay, once again I have to do, insert this one. Duct is done, fuselage is done, main wing is done, horizontal stabilizer, only vertical stabilizer we have to select. Okay, so we have all these parts. Now we have to do assembly. Okay, so to do assembly of this model, or all these different parts, what we have, part 1, part 2, part 3, part 4, part 5, that is our engine, fuselage, main wing, horizontal stabilizer, vertical stabilizer. Okay, so out of all these 5 parts, you have to fix any one part, okay, as a constant, like this. What you have to do, you have to fix any one point, okay, and you have to call that point or that part, okay. Out of 5, any one part you have to fix, okay. Out of 5, 1 to 5, any one part you have to fix, and you have to call that as a center point or the reference model, okay. So for this reference model, you have to use all other parts. Suppose you have called your fuselage as a reference model, okay. So with respect to the fuselage, you have to assemble all the other parts, okay. So I'll just show in the open VSP. So to fix this fuselage, you have to maintain all this translation x, y, z, 0, okay. So see here, we have our duct or engine, okay, x form, which means for this case x location, which means this wing is located at some location along x-axis, along y, and along z. Similarly fuselage also, okay, fuselage is like constant, okay, that is what we need. And main wing is also constant, okay. And our horizontal stabilizer also same, vertical stabilizer also same. So what we have to do, we have to select any one model. I'll just select the fuselage because among all the parts, fuselage is the heaviest part, or we can say the size of the fuselage is larger as compared to all other parts. So I'll just fix this part, okay. With respect to this part, I will assemble all other parts. So I'm fixing, in the sense I'm maintaining x location, y location, z location 0 0 0, x rotation, y rotation, z rotation 0 0 0, okay. And rest other parts I will just select and I will translate and I will fix, okay. So let's use the top view, okay. So I will not do anything to the fuselage, okay. I'm just maintaining a constant part, or I'm calling my fuselage as a reference part, okay. So to that reference part we will assemble all other parts. So I'll just select the wing, main wing, okay. We know that according to our assembly, what we have to do, we have to place our wing at a distance of, okay, so along x we have to translate. I just mention here, let's go to new whiteboard. Yeah. Okay. So this main wing what we have is located at a distance of, let me paste this one. Yes. Okay. We know overall length from here to here. Okay. This one. So extra this one from here to here. The calculated length I'll just mention. Sorry. Okay. So along x, it has to translate from this nose point. Okay. Because we are fixing this component fish touch. So I will call this one as 0, 0. Okay. And here we have axis. That may be x, y, z. I will call this one as x, y, and towards the screen that is z. So along x, I will translate our wing at a distance of 45 feet. Okay. (43 feet 10 inch). So according to the calculation, that will be 45 feet. So we will use that in a x location. So I just type 45, enter. Yeah. So you can observe wing has been translated along x. Here we have x-axis, y-axis, and z-axis towards the screen. Okay. So now after this, we don't want to do any disturbance along y location because the wing is attached. Okay. See, if we do disturbance along y location, then wing component will get detached. Okay, so we don't need a detached component, we need an attached component. So that's why just let it be 0 itself. Now along z, let me change the view. Okay, let's take the left view. Yeah. So exactly that is at a midpoint. Okay, which means along z location, exactly that is at a midpoint. So we don't need there. Okay, we have to place our wing little bit down. Okay. Yeah, so just mention that value here. Let's take that view so that it will be clear to all of you. Yes. Okay. So suppose this is our wing which we are placing. Okay. From here to here. I'll just take wing section. Okay. This one. The calculated length that is along z location, that is, yeah, we know already we have given x. So we have to take little bit down as I told. Here we have 0, 0. Okay. So this is our z axis now. Okay. So what we have to do, we have to move down. So that's why I'll just select z location. I'll go back. Okay. Because I have to fix little bit down. that is at a distance of minus 2.527. Okay, because this is our reference point. Okay, from this reference point, upward is positive, downward is negative, left side is negative, and forward direction, that is positive. So we are going down. Okay, here we have to look at our wing, which means from here to here the calculated length is minus 2.57 feet. Okay, so that is minus 2 point, so already we have minus 2 point, so just equal 527. Enter. Yeah. Okay, so wing has been assembled perfectly. Now what we'll do, we'll go to next component, that is our horizontal stabilizer. Here we have our horizontal stabilizer, which is default placed nose side, so we have to move this one. So I'll just use X location to move forward. Okay, so just I will type 50. Yeah, so we have to place here. Okay, so from here to here, let me first translate this one. So I'll just use top view. Okay, okay, so we know overall length of our fuselage. Okay, that is 129.496 feet. What we have to do, so according to calculation we know this length. Okay, so I'll just give overall length from this nose point. Okay, which means from this point to this point. Okay, that is 108 point, yeah, 108 feet itself. So it's already 100. I'll just type 108, enter. Yes, now it's perfect. Along X we have translated perfectly. Let's change the view. Let's observe from the side view. Okay, from side view it is not fixed perfectly. Okay, so which means what we have to do, we have to use our Z location. Okay, to fix like this. Okay, so here we have our view. See here, as I told, this is our reference 0,0 point. Okay, I'll just extend this axis. So easily now we can say, okay, this what we have, the horizontal stabilizer, it is above the neutral line. Okay, which means positive. Okay, wing has been placed below this 0,0 line. Okay, or neutral line or neutral axis. Okay, so that's why we have used minus 2.57. So it is placed above the neutral line, so that's why we have to use plus. So the calculated length or the distance of this one is 5.57. 5757 feet. Okay, 5.57 feet. So we have to type 5.57 57, enter. Yes, it is assembled. Now we have to use our next component, that is vertical stabilizer. Here we have our vertical stabilizer. Okay, so I'll just move the vertical stabilizer forward. Yes. Now we have to change the angle because the vertical stabilizer, it is parallel to the ground. We don't need that vertical stabilizer parallel to the ground. Okay. Yes, you can observe. Okay, it should not be like this. Okay, so we have to change its view or its position and also the angle. Okay, so we have to use x axis. Okay, it is along x. Okay, along x 0, angle is 0. Okay, so I'll just change the angle to rotate this one. Okay, that I'll use 90 degree. That's perfect. Okay, so let's use the side view. Okay, okay, now what we have to do, just we have to translate along z. Okay, yeah, here we have to place. Okay, see, uh, horizontal stabilizer has been placed from this neutral line at a distance of 5.57 feet, and for this case we have the point. Okay, distance from the neutral axis, that is 6.5 feet. Okay, so I'll just type 6.5, enter. Yes, assembled. Okay, so we have done with the vertical stabilizer. Now last component, that is duct or engine. So okay, here you can just use this option to translate. So you can select ellipsoidal. Okay, all of you select ellipsoidal. Okay, because already it is calculated, which I have added. Okay, so select ellipsoidal. If you select ellipsoidal, okay, then you will get the parameters with respect to the ellipsoidal. Okay, and design parameter already have done, so I just mentioned here. Okay, so just add that value. Suppose you have given the width, height and shape. Okay, by using your ellipsoidal, as I told you, you can use okay, we have tried pod, it will not give that perfect geometry, so just use ellipsoidal or stack. Okay, now I'll just assemble this one. We have our top view. Okay, so duct or engine We have to assemble this one also below the wing. I'll just change the view. I'll just move forward. Oh, sorry. Okay. I will come to X form and I will translate this one along X 50 feet. It is not perfect. Okay. Now I will change the view. I will select the front view. Okay. I will translate along Z just below the wing. Okay. So you can place here or here. Okay. Location is not given. So approximately you can place. It should be below the wing itself. Okay. That you have to ensure. So I'll use the left view. See, for assembly, if you are disturbing with the components, then just select the components. Okay, which component is disturbing to you, or which component you don't want to see. Select and hide. Okay, where you can hide your component. Show or no show. Okay, if you click no show, it will not show you. If you click show, then it will show you. Similarly, you can select wing. You can show or you can no show. Wing we need because there only we have to place now. So I'll just select the fuselage. I'll use no show option. Okay. Yeah. Now I will change the view. Let's see. Now I can observe clearly. Top view, okay. So we'll use front view. Okay, little bit down. Oh, sorry, I'm disturbing the fuselage. Okay, we have to just fix this one. Okay, here we have our engine. Little bit down, okay. I just round off to 3 point minus 3.2. Put 1. हाँ ये बंद है.
क्या चलेगा सर? सर B का क्या B का क्या बोला? हाँ जिंक उसी में सर उन्हीं तो सर
सर बड़े हमारे क्लास है. Okay, so we'll just okay, let it be like this. Okay, now we will change the view. Front view. Little bit back. Okay. Yeah. Yes. Okay, let it be there itself. Okay. Now what we'll do? We need one more such component. Okay. So just we will take the symmetry. That's it. I'll just select the fuselage and I will use show option. Okay. So I will copy this and I will paste. See here we got that pasted component. I'll just translate that one along Y. Okay. And also I will translate alongside. Okay, it is here. It is here now. Okay, so what we'll do, we'll delete this one. Once again, we will select. Okay, yes. Let me check the view. So here we have front. Yeah, now it will be easy to copy and paste. Yeah, so I'll just copy once again and I will paste. Okay, yeah, here we have that pasted component, which is a symmetry component. Okay, now we need that component opposite to y. Okay, opposite to y. Here we have our y direction. Okay, this one is positive. We need one more component, which is already we have pasted. Okay, same side, that is minus y side. So I'll just type minus 25.83. Okay, enter. Yes, okay. Minus, okay. Okay, I will translate this one. Yeah. So use your front view. Okay. It is far away. So I'll just select this component and I will give same parameter. Okay, 60, 25. 60, enter, and 25. Okay, that side we don't need, we need this side. So minus, it is going down. Okay, we'll take this side. Yeah. So I'll just reduce this to 30. Okay, 20. Okay, let's take 10. Yeah. Okay. Okay, so we will just use our minus 35. What we have, we will use minus 45. Okay, I will select this one. Okay, so we'll type minus 25. Yeah, just little bit. So along X. Okay. Let's view the top view. Okay, just we have to disturb along X, so I'll just type 0. Yeah, and let's check front view. Okay, so along Y minus 45 for this, and for this 25 60. Okay, yeah, so we'll select left view. Okay, so now you can share this one. Okay, so you have to select all and share. Okay, if you want to change the color or the material, okay, you can select the material or color. Okay, and you can go to file, you can save. Okay, so we have done with the assembly of the commercial plane. Okay, the second model is done, and already it's time up. As we know, we have seen the assembly. It will take time because we have to calculate the things. Okay, and some things already calculated, some are not done, so that's why it took time. Okay, so that's why it's very important to know the specifications of your geometry correctly. Okay, if you know the specifications and geometrical parameters, then your work will be easy in the open VSP. Okay, so we have done with the commercial plane. Okay, tomorrow session we'll start our next model, that is helicopter. Okay, yeah. Now once you done with the assembly, if you want to capture the image or if you want to take the screenshot, okay, of your project or of your model, then what you have to do is just you have to go to file. Okay, before file you have to ensure that you have saved your file. Okay, so you can go to the screenshot option. Okay, so select this one. It will ask you width and height, and just capture this one. Okay, if you want to change the ratio, you can change the ratio. Capture image and give file name. I will just use this file. I'm in the directory. Yeah, so assembly of model to this commercial plane. Okay, exit. Also you can take a single right ISO or left ISO picture of your model. Go to file, sorry, window, and take screenshot. Okay, so before taking screenshot, if you want to change the background color, okay, you can change the background color instead of white if you want some other color. Okay, so you can go to background, you can select any other color. Okay, if you want to place the image or if you want to insert the image, you can insert the image. I'll just maintain same. I'll just save the picture in a screenshot form. Okay, second image, accept. Now here in this folder, you can observe the picture format, that is PNG format. Open this one. Here we have our model picture. Okay. So we'll stop here. We'll continue tomorrow. Any doubt, Ashwin?
No, sir.
Okay, then we'll
Sir,
continue
when
tomorrow.
should we give the full assembly file, sir? Submitted?
This one, you just submit me before 10th of this month, because we'll be doing next model also. No?
Yes, sir, because I have to just do the fuselage, sir.
Sorry.
I have to just only finish doing the fuselage, sir. I've done all the other parts.
Complete that. Complete that and submit
Okay, sir.
before we complete our next model. Okay,
Okay,
that is
sir.
helicopter. Yeah.
Okay, sir.
Okay, then we continue tomorrow. Yes, sir. You can stop the screen share. We'll continue tomorrow.
Yeah, sir. Thank you, sir.